So we're gonna go to 2.3 where they say consider compound F. Now we're gonna write down the UPEC name of its positional isomer. So you see compound F. We can move this to any place we want the oxygen atom. So we can be able to name its positional isomer. Basically, this is Pentanone or something like that. So basically, this is pentanone. Yeah. So with that, we can move this to any position that we prefer, and we get our positional isomer. So can you just change yourself and try to come up with a positional isomer? And I'm gonna give you like two minutes, so you can just give me the answer after like 2 minutes, after you've thought it out. I think this is, yeah, it's 2 marks, so 2 minutes.
What's the question again, sir?
Name the positional isomer of F. The positional isomer. Pentanone. I'm sorry, Tomlin, are you aware of like the naming scheme and stuff?
Yes, sir.
Yeah, so how do you call F?
What does it mean?
So you look at, so you can see that B, they say pentanol, and F has like five carbon atoms. So I'm just asking for the name of F because I said it, but I'm not sure about the way I said it. So
Ketone, sir.
sorry.
The ketone.
Yeah, the ketone.
Doesn't mean like how I see it's a ketone.
Yeah, but what's the name? Because I said the name, but I'm not sure if I said the correct name. Like now you're not answering, we're not answering the question of the positional isomer. It's just that when you look at F, right? Can you name F? Not the positional isomer, just F as it is.
A ketone, sir.
Yeah, it's a ketone. the name of the ketone? That's the question.
I don't know that, so.
Nah, man. I think ketone name I think it replaced the ketone. The ending E is removed and replaced with 1. So in this case, it's basically pentane. Pentane. And the E is replaced with 1. So pentanone. So that's the name of this. And now we must find the positional isomer of pentanone. And to make a positional isomer, you can just move this oxygen maybe to here. Yeah, you can only move it to here, because if you move it to this side, then you're gonna start counting from this side you're gonna start counting from this side to this side. But if you move it to the middle, that's the only position where it can be without where the name can change. Because if you move it from, let's say this is carbon number 1, this is carbon number 2, this is carbon number 3, this is 4, and this is carbon number 5. So in this particular case, they want us to move the oxygen to any other carbon that is attached to 2 carbons. But if you move this from carbon number 4 to carbon number 2, you're gonna start counting from this side. So if you move the oxygen to carbon number 2, you're actually gonna start counting from this side, and number 5 is gonna be number 1. Number 4 will be number 2. Number 3 is gonna stay the same. And this will now be carbon number 4. And this will be carbon number 5. So basically, if you move the oxygen to carbon number 2, you basically have the same thing. But if you move it from carbon number 4 to carbon number 3, that's a new isomer. So that's how like the positional isomer is gonna be found. So basically, you're gonna move this to carbon number 3, and after that, write down its UPAC name. So do you think you can do that? You think you can be
So
able
is it
to? Sorry?
pentanone?
Pentanone. Is that like actually usually the numbers go here. Penta 3 all. Yeah, I think the one you said is correct. So it's gonna be pent 3 known. Yeah. So that's gonna be the positional isomer of F. But now they want the chain isomer. Do you know what is meant by chain isomer? Because
No,
you guys
sir.
Sorry.
No, sir.
So basically, this is the straight chain, right? So you can actually, so since this is a straight chain, an isomer, they have the same chemical formula, just difference here and there. Sometimes it's via the structure, sometimes it's via the position of a certain atom, of a certain element. Sometimes they perform different functions, but the chemical formula is still the same. So what's gonna happen here is that you can just say you have 5 carbons. So the chemical formula has to stay the same. So you can just do this and have this here and this here. This. And there's gonna be a carbon there now. And 2 carbons here. So from the picture, from what I've drawn, you can see it's still gonna be the same chemical formula. You still have 1, 2, 3, 4, 5 carbon atoms. But now the chain is no longer the same. Basically, oh, I'm sorry. This is not gonna be right. It's gonna be somewhere around here. This carbon has to be moved to here. Because now if you look at this, the chain is no longer the same. The longest chain no longer has 5 carbon atoms, it has 4 carbon atoms. So this change indicates that this is a chain isomer of pentanone. So once you change it to be something like this, it's gonna be let's say this is number 1, this is number 2. So let's say it's gonna be 2. Oh, I'm sorry, 3. 3 methyl. Basically, I would like to call it 3, but I forgot one thing. This has to be 2, since when naming an aldehyde and ketone, the functional group has to be at the end. So this is actually number 3. This is number 4. This is number 2, and this is number 1. So do you understand like how I went from pentanone to 2-methyl butanone?
Yes, sir.
So this is the chain isomer. basically you just change the longest chain. Let me just stop drawing here. So now we're gonna go to 2.4. They say during the reaction of compound A with E in the presence of an acid catalyst, two products are formed. For the organic compound formed, write down the UPEC name, the structural formula of its functional group. So basically, we're gonna add A and E. Where's that eraser? So A is a carboxylic acid, and E is is an alcohol. So first you're gonna have to know the formula of A. So A is methanoic acid, so it has one carbon. COOH. H. So do you understand the formula for carboxylic acid?
Yes, sir.
Okay. So now we're gonna have our carboxylic acid being added to 1, 2, 3, 4, 5, 6 hexanol. Yeah, hexanol. So it's gonna be added to E, which is an alcohol. So from your notes, did they teach you what happens when like an alcohol meets a carboxylic acid?
I think so, yes, sir.
Okay. Oh yeah, sorry. This is E, ethanoic acid. Oh, let me just rub this out because it has to have one carbon for methyl. So yeah. So from that, what products are formed when like an acid interacts with with an alcohol? I mean the products that are formed. Because I can't say like I'm 100% sure about the products that get formed when an acid and an alcohol meet, but
Is it acidification, sir?
sorry.
Acidification.
Yeah. So basically, what's gonna be formed is water and an ester. So if we know that water and an ester are gonna be formed, our job now is to find out which ester is gonna be formed. So you should remember that this is hexanol. So it has 6 carbons, and this has 1 carbon. This OH is gonna be eliminated alongside this H to form our water. So what you're gonna have left now is HCO plus OC 2, 3, 4, 5, 6. Right. So you're gonna have something along this. You're gonna have something like C6. You're gonna have C, sorry, 1, 2, 3, 4, 5, 6. So you're gonna have C6, H, 3. This has 3 hydrogens. This has 2 hydrogens. This has 2 hydrogens. This has 2 hydrogens. 2. And this one also has 2. This one only has 1 now. So 1, 2, 3, 4, 5. That's 10, 13, 14. Let me just make it 13, since this one has to be alone. O C H. You understand it?
Yes, sir.
Yeah, so this is the ester that's going to be formed. So from this, do you know how to name an ester? So did my PC just freeze? Okay, so do you know how to name an ester?
Yes, sir.
Okay. So what do we call this one? Like, can you just name the one that we formed now? Firstly, you need to remember what we used. We used methanoic acid and hexanol. Oh, that's gonna be hexyl methanoate. Yeah, I think it's hexyl methanoate. Is that the answer that you got?
Yes, sir.
Okay, yeah. So basically we formed hexyl methanoate. That's the UPAC name of the organic compound. Now we're gonna need the extractional formula of its functional group. Basically, when they say the functional formula of its function group, let me just erase this. Basically, it's gonna be C and H 2 and plus 1 O 2 CH. Something along these lines. Or you can just say C. That's gonna be 7 CN H2N O2. So it depends on which way you prefer. So is that fine now?
Yes, sir.
Okay. So as they say that compound C is reacted with high temperature and pressure to form 3 carbon alkenes, P and Q, as shown below. So now they say write down the type of reaction that takes place. So when they say something reacts in high temperature and pressure, what reaction do you think takes place? Because honestly, I don't think I remember the reaction that takes place in this one. As much as I wanna say, what's that thing? What's the thing when you burn something? Combustion, but I don't think it is combustion. So do you know the type of reaction that takes place?
Is that cracking, sir?
Cracking. Now I think for this one, let me just check it for you. Cracking in chemistry. Yeah, that's actually correct. So the reaction that takes place is cracking. And now the molecular formula of compound Q. So to form a 3 carbon alkane. Oh, okay. So if you know that P has 3 carbons, so yeah, I'm pretty sure like this is gonna be like our last session. So after this, we'll be done. I think like after 2.5.3, we can meet again on Tuesday and continue with another chapter of organic chemistry. Is that fine?
Yes, sir.
So since P is an alkene, we know that the formula for alkene is CnH2. So it's gonna have a double bond here. it's gonna have a carbon and one here. So we're gonna have this. Yeah. Let me just drop this out. Basically, I already gave you the answer for 5.3 for 2.5.3 because they want the structural formula of P, and I just drew it. So anyway, you got this is 2.5.3. So since we know that compound C has 10 carbons and 3 of them are used to form P, the seven that are left are gonna form Q. So basically, since Q, they already told us it's an alkane, we already know an alkane with 7 carbons, that's gonna be heptane. And an alkene with 3 carbons, that's propene. So basically, this is propene. Yeah. So from this, I can hear like you know the concepts of organic chemistry. It's just that the question, maybe the way the questions are structured is the problem. But if you practice them more, like you are gonna get better because you have the basic knowledge, but it's only the structure of the question that confuses you. So I think this is the end of our session.